old calendar, on this day, October 22nd, I put a note that the calendar ends. Use this link to go to the new calendar, and then the link in that calendar gets you to this one. But I did do the last 2 weeks, and there's still some people still have to finish up some stuff. So get rid of the old calendar after you get into this one, and then bookmark this one. The reason I like it too, web pages get less useful the more you have to scroll all the way down, right? Didn't it get annoying when you had to scroll down to page 2? So I like restarting, but I also still believe in quarters. We are actually in what would be called quarter 2. We are over halfway through the semester. So I call this the second quarter calendar. And what's nice about it now, on one page, you can see the end of the semester. We do have final exams, but really what they are is just another 100-point test that encompasses everything. Don't freak out about that. Most students did really well on that last year. Because it's just the basic multiple choice. Do you know it or do you not kind of thing. All right, so back to our notes. This is 4-5. And the argument why this is in this section, when we just did square roots and cube roots and all that other stuff, now we can incorporate those into these operations. I guess that's about the only thing I can say about that. Because sometimes, you come in on a Monday, and I'm going to shove 45 minutes worth of math notes in your face here. Why? Where did we just did square roots? What are we doing? And that's the argument for that, I guess. But that's not how this starts. This doesn't start with a square root. It starts with algebra. So if you don't want to write this down, that's fine. Because really it is pretty simplistic. If you read the directions, how do you find the sum and the difference of these functions? This is how you define it. You actually do it. And then all this requires, you know what this was? This is when you first walked into my class. This was chapter 2. If you remember, we added like terms. And I'm going to put these in parentheses, but ask you a question. Do these parentheses have any meaning? 3, 2, 1, go. No, they don't. All they are is just to, they're like place markers for replacing the name f, which is really f of x, the name with what it's defined by, its functional value, its expression, right? And then you know that this is as simple as it gets. But what you want to do is add these like terms in order so that you can get this in descending order. All right, don't want to waste a lot of time on that. Don't see a lot of people writing this, and I don't blame you, even though I was just very judgmental about somebody last hour not taking notes. And then they're like those cat meow students that don't take notes. Then they go home and they don't know how to do their homework. When my notes mirror that, drives me crazy. F minus g, 3x plus 4, minus x squared minus 5x plus 2. Ask you the same question. Do the parentheses have any meaning? 3, 2, 1, go. Yes. Why? What do we have to do with that minus sign? Distribute. You may take your time, or it may go faster. The first thing you might write is this step. And then like terms. So in this case, the parentheses definitely have meaning. Biggest math mistake made is not distributing a negative. I felt like I put -2 last hour. No one said a word. Maybe I didn't. No proof of it now. Actually, I do. I just want to see. I'm curious. Nobody cares, Mr. Samulus. Oh gosh, never mind. Something. Look at this program. What happened here? Forget it. This thing's freaking me out. Something weird happened. Oh gosh, now we got what is happening? What is going on with my notes? Is it me? Am I just freaking out, or did everything just disappear? I don't know what to do. Oh, there we go. I hit it. Okay. Woo. Okay, let's not mess around anymore. Boy, the program did not like that. All right, I don't think I have to do this, right? Do we have to add or subtract again? There's something wrong. That took like a minute for that to come in when I wrote here. So we're definitely dealing with an issue here. F of x equals 2x squared. This is weird. I'm writing, and then it comes up like a half a second later, so this is very hard for me to concentrate. Minus 1, and then g of x. I'm just writing this down here so that you understand some more algebra here. Okay, I might freeze the screen. Might do a little computer stuff off to the side here because there is something going on. Maybe I'll get rid of my picture, help the memory. Okay, close, open. Hopefully that does work and makes it work a little bit better. All right, so I'm gone. I deleted myself from the video. Hopefully the video is still smooth. Blah, blah, blah. FG. And then GG, what? Ah, and that gives me memories. My kids used to call great grandma Gigi. Anyway, I know. So here's FG. It's very simple. F or f of x, and they're lazy. It should really say f of x times g of x, but that's really what mathematicians are. They're lazy. They come up with these notations to write less stuff. Very true statement. By the way, I forgot how many people were here on Friday. Do I have to compass you? Right? Oh, Thursday. Okay. I don't know if I have anyone signed for Compass, so I'm gonna get a mean email from my boss. All right. You guys were supposed to sign up for Compass on Friday. Anyone sign up? Like, because they could sign up now, you could do it yourself. All right. You were supposed to be taught that. Weren't you taught that in Compass Friday? Right. Okay. I was hoping I'd get picked, and I think I checked right after. Nobody picked me. Aw, poor Mr. Samuelus. And then g of x is 3 minus 2x. And then this is what this means. You have to multiply them, which requires cousin of FOIL. All right, not really FOIL because there's more than 4 multiplications. And then you just draw the lines, minus 4x cubed. So this is very much like you started the year. This was day 2. This is the very second thing that we did. Fumble! 3, and then minus 2x. I was baffled. The handful of students that struggled with being able to just get those lines moving, do these lines, and just control your who gets multiplied by what. Keep everything organized. All right. Those that were sloppy writers and couldn't draw those lines got destroyed and started the year rough. Okay, so there's negative 4x to the third. Made that 3 a little bit too large. Here is, and get that minus in there, minus 8x squared. I'll underline here because those circles kind of got in the way. Plus 19x. Hopefully I didn't make any mistakes. That seems a little different there. Gone, and then plus 3. Okay, and then no, you don't factor in this section, except for a specific type I'll show you later. You simplify. Some students try to get confused. Wait, do I factor? There's a big difference between factoring and simplifying. You're simplifying. You're writing a polynomial in standard form when you're done. Right? So just trying to think about some things that go wrong. And then GG, that just means you take a function G, what? Touchscreen, and multiply it by itself. By the way, the closing the program and opening it up did help. So you're taking G and multiplying it by itself. This is a FOIL. I'm gonna Leof. What? All right, so here's negative 2x times negative 2x, which is 4x squared. I'm gonna do L first. And then you should be able to handle this. This is negative 6x and negative 6x, which is negative 12x. And then I'm going to do first the last. 3 times 3 is 9. And then I have it in standard form. So, a Leof instead of foiled. Liof. Made up a new thing here. Okay, now, here's the one time you might need me. Really, it's the first time this is going to happen. This next mathematical concept. Oh, by the way, shucks. I have to go back up to the notes. I do this often. I forgot about doing the domain. Okay, so I have to go back to the microphone and admit my mistake. Okay, so you have this spot, but I'm going to pause you for a second on this one. Like my nose thing is off there. And go back up here, and I forgot about this. How do you combine, multiply? Don't write this down. How do you find the domain of the resulting function? Let me take all of these last polynomials and just tell you something in general. A polynomial, when it's just a polynomial, the domain is never an issue. The domain of all of these answers is negative infinity to positive infinity. Okay? Think about square roots. You have a domain issue because you can't take the square root of a negative. That was like one of the first few times we had a domain issue that we had to discuss. All right? So not a big deal here. So go ahead and say that for these first four examples. Now, needing me maybe for the first time in these notes, at least something different is going to happen here. And if I didn't show you this, 90% of you would get this wrong. So I do have a value here. It's dividing. I think before I do this question, let's put a little note to self off to the side when you're dealing with division. And then three special cases. What is, number one, 0 divided by 6? Let's get a group response in this in 3 seconds. I just picked 6 out of the air. It has nothing to do with this question. This is a thought bubble. What's 0 divided by 6? 3, 2, 1, go. 0. This one's okay. Okay. And then what's 6 divided by 0? 3, 2, 1, go. Undefined. I'm going to do this for the first time in forever, or not possible. It's called a division by error, zero error, and equate this to grade school division. The reason this doesn't work is, and you don't have to write this down, but the reason why actually is helpful for people to be able to memorize things. When you know why, then memorization is less and less. This is what happens with the division garage. 6 divided by 0. Hey guys, what number times 0 equals 6? So I could subtract this and get no remainder. Is there any number multiplied by 0 that equals 6? This is the reason. This is why that doesn't work. All right? And I think it's helpful to know that. All right, I'm going to erase this and actually do the first one. Tell you why this one works. 0 divided by 6. What number times 6 equals 0? What's the answer to that, everybody? 0. This is why this one works. Things can always be explained. They're not rules that you just have to remember as robots. That's why I call you robots sometimes. At least my cats, students, they try to just get the rule and memorize the rule and not really understand what's behind things that are going on. Hey, I got a really good question. What's 0 divided by 0? Whoa. 3. I'm not going to let you think about it. 2, 1, go. Ooh, I love it. 1. How many people said 0? I thought I heard a few. Did anyone say undefined? The answer is actually undefined. Okay? And you can prove this on your calculator that this is still undefined because the rule is you can never say it. You can never divide by 0, not even 0. Right? So 1 is a valid answer too because you're thinking something over itself. Go ahead in your spare time, take 0 divided by 0 on any calculator. It'll say not going to do it. It'll say error. This is an important concept for what's going to happen with this. Okay, so with all that being said, knowing these basics, because remember, variables are just numbers anyway, f divided by g is f, x minus 7, divided by g, 2x squared minus 13x minus 7. And I will tell you, your book is your friend a lot of times because they want this to happen. Right now, you may not see this, but the bottom is factorable. Take a wild guess what one of the factors is. Take a wild guess one of the factors. 3, 2, 1, go. X minus 7. I guarantee it is, because the book wants this to happen for you. A lot of times this occurs. Okay, so if that were true, then what would this first thing have to be here? Good FOILers, good factors, 3, 2, 1, go. 2x. Not enough people said that, and it actually makes me furious. If you still don't know that 2x belongs in that blank, you should be jettisoned out of this classroom. Gone. Because good FOILers say it. Good factors. This is how we unfoil. 2x times x is 2x squared. And then what times -7 equals -7? 3, 2, 1, go. 1. Now I'm questioning, does this? Because I did this weird. I didn't really think about factoring, but I thought the book probably wants this to happen. Is this true? Yes or no? Okay, that's all I have to look at, the middle term. Because obviously 1 times -7 is -7. 2x times x is 2x squared. The middle term does happen. -14x plus 1x is 13x. Because now here's a problem. I actually wrote this off to the side, and Mr. Samuels with these thought bubbles sometimes hurt my head. What's 2 over 4, by the way? 1 over 2. But you could think of this way. 4 is 2 times 2, and then you could cancel these equal factors. And that's how it's 1/2, right? Right? So the equal factors can cancel as long as they're separated by multiplication. Because really, that's what's happening with this. Gone. When binomials are exactly the same above and below, they're equal factors, and therefore they can be canceled. So this final answer of this division statement is 1 over 2x plus 1. And I'm not sure if you've ever done that before. I'm going to pretend you haven't. Because even if you have, this is one of the more challenging things students can't wrap their minds around. That's being truthful. Okay, now we got a real problem. What is the domain? Well, this is why I went through all of this over here. This is why I went through all of this. What is the domain? What can I plug in for x? Or a lot of times it's better to think what I can't. It's like square roots. We paying attention over there? Reaching in the bag? All right? Square root of x. Can I plug in 0? Yes or no? Yes. Can I plug in -1? Yes or no? Not in the real world. All right? You want to keep it real. So that was our first domain issue that we ran into. So what can't I plug in for x here? 3, 2, 1, group. Go. -1/2, not 0. 0 is actually okay. 2 times 0 is 0 plus 1. That just becomes 1 there. It's actually -1/2. And I'm going to give you the old Algebra 2 or maybe Algebra 1 way of stating this domain right here. And it's actually a not equal to sign. And the book might do this. I listed some answers out of your book today. And they may use the not equal to sign. But then I have another question, guys. Look over here to the left. What is 0 divided by 0 still? Say it. Undefined. Because now, when you looked at I factored and canceled, you still cannot plug in 7 into the original. Because if I plug in 7, I get 0 over 0, which is undefined. So 7 is still, even though it factored and canceled, still a naughty value for the domain. Right? And that's why I went through all of this. That's why I went through this. This is why this is still a domain issue. Because we're talking about the original, not after you simplified. So the meaning why is always so much more powerful and better for students. And those that really focus and pay attention and pick up things quick, you appreciate those things. Then your math is more solidified as you move on. Now here comes the interval notation. You know what a not equal to sign actually means? It means the domain is all real numbers. And I like doing this with my CAT students. Yeah, the domain is all real numbers, except these two little conditions here. How do you do this in interval notation? This is the only way. And this is why I wrote this so far apart. This is the only way you can exclude these two specific x values. And that essentially is what that statement. So you got that down, sir, with your arms folded back there, almost about to fall asleep on me, looking so comfortable? Arrgh. You have no idea, parents, what we deal with on a daily basis. Then they go home and say, I don't understand anything. Did I say good morning, by the way, today? I'll say it again. Good morning. I felt like I got a little crass there. But there are some things that are unacceptable. I do know it's a Monday, but do better. Okay, so hopefully you understand that that's all real numbers except. And that's what a not equal to sign actually means. So I showed you two different representations of that concept. Hey, let's do one more. And almost the exact same thing occurs. Oh, yeah. Mr. Samuel's in a special mood today. You do have a responsibility to do your parts. All right, I think that's being lost more and more as the years move on. Identify the rule and domain for whatever for each pair of functions. You know what? I forgot to say this. I made a really good idea, a really good point of rule. That just means simplified expression. What do you mean rule? Rules. It's always about rules with these old people. That's not what it means. Almost did a P into an R there. So rule means simplified expression. Okay, so do the stuff, and then, if there's any algebra I can do the algebra. In this case, with the division question, the algebra is, does it simplify? Now we'll speed this one up. G is x plus 3. And I would like to put those in parentheses. F, I don't know why that came up, the touch screen, I wish I could disable that. And then at this point, as we move on, and I have something brand new to show you after this, we got to go fast. Again, if you still don't know how to factor, it's got to be over at this point. What multiplies to negative 18 and adds to negative 3? 3, 2, 1, go. And you could have switched them. I heard good enough there. It's negative 6 and 3, so it's x minus 6. That was 5 times to write an x. Love you, computer. And then, of course, x plus 3. And we can see the book really enjoys that this occurs. All right. Now that I see this in factor form, I can cancel this, and the final answer for the simplified of g divided by f is this. Then, of course, the domain, going to speed that up too. It's all real numbers. So I like doing that with my CAT students. It is all real numbers except 6 and negative 3. Negative 3 still, because 0 divided by 0 is still bad. And that's the only way that you can write it. I need a U. Got it in there. Nice. I do like doing that now. I do that with my CAT students, write that like that. All real numbers except negative 3 and 6. That's the only way that you could write the domain. Right? So domain issues. Remember, our domain for a polynomial is all real numbers. So it's mostly what's going to happen today. Fractions, we got problems. Okay, let me do this way. This deals with composition of functions, but you need to understand this thought bubble. This is another thought bubble. Reversing this from first hour. I started talking about composition of functions, and then I went over to this thought bubble. So another thought bubble off to the side. Our last one was dividing by 0. What could be the issues there? And the fact that we can't have 0 in the numerator. It's not a problem. Okay, and I should have a highlighter on this x as well. And all this is I defined a function. F of x is x squared plus x. Okay, just tell me what the next thing is. Don't give me the evaluation, but what would it be? What would I write next? So what's f of 2? 3, 2, 1, go ahead. See, that's what happened last hour, and I was shocked. So one more time, what's f of 2? 3, 2, 1, go. 2 squared plus, what's next? 2. Okay, that's what I was asking. See, because what we're going to do next, we have to understand this basic function notation, and the word is just substitution. This is what's happening. Hold on. Substitution. Oh, I ran out of room. What a cool word that goes down and then right. It's really what it is. That function notation just means substituting wherever there's an x, put a 2 in its place. So what's f of y? 3, 2, 1, go. There we are. Y squared plus y. I swear to dog, those that don't write this, you're the ones that are going to screw this composition of function up next. Because you're not in tune with the notes and you don't care. What the heck is this thing? Take a guess. What's that a picture of? 3, 2, 1, go. It was an apple. I thought someone was going to say cherry. What? If I wrote a math book, I would make up new variables. They don't have to be X, Y, Z. They can be a dog, a cat, an apple. It doesn't matter. What's f of apple? 3, 2, 1, go. Apple squared. Go ahead. What's next? And the point is being made that it doesn't matter what I put in there. Whatever I put in there, I replace X with that. So why do we have a big deal about the last one? Because this is why composition of functions get screwed up. Not understanding the last thing. This is when students start making up stuff. They lose our last three ideas and screw up the next one. So the way I look at it is this. In all of these cases, it's like X is just a place marker. It's like an empty place to replace it with something else. Think of that for the first one. Wherever there was an X, I got rid of that X, and then I put a 2 in its place. So 2 went in this place marker, and that's all that happened. And no one has a problem with that. Nobody. But then when I write the next thing, people are like, wait a minute. So wherever there was an X, I get rid of it, and then I put an X minus 3 in its place. That's exactly what happens. What do I get students do? They put an X minus 3 and they multiply by X, and they shove them together. All right? And that's what I get seeing on this. It's just the things go out the window. Right? So if you understand that, and this is not a problem, composition of functions are going to be infinitely easy. All right? And I'm going to reverse what I did with them and do... Don't write anything. Close your eyes for a second. I'm going to do this last. Because this is actually different than what I kind of want to hammer with what I had over there. Okay, so here's what a composition of function is. Now, after that, setting up the idea, this is actually what it is, and I have some words to put in here. And this is what you should write. So pick up your pen back there, and at least pretend. Start drawing pictures I won't see if you're actually taking the notes. A composite function is a result of applying the rule of one function, f, to a rule of another function, g. And I wish I could zoom in on this, but I'm going to rewrite this up here so you really see the different operation. And then Caleb back there, we're in this now. This is what you asked at the beginning. What is this? And how is that different? So that's really what you want to write in this position. F open dot g of x. That's what that says there. And then I'll use the correct terminology to fill in these parentheses. I think I might have said it, but I'm going to write it. How you actually say it is this. F of g of x. That's how you say what I used to say fog, or FOG of x. Not really an O, though. They will tell you this is why you take notes, because if you ask me in the next quiz, hey, what do you mean find FOG of x? I'm going to tell you to sit down, because that's your job. You're supposed to know that as a mathematician in my class, after it's been expressed, that you need to know that's what this means. But you don't know what that means yet. I'll tell you how the operations work. By the way, the smartest way to write this is like that. Multiple parentheses. That says the same thing. F of g of x. Parentheses, parentheses. And I really love how this book color codes some of these when we get into the notes there, because the color coding will help your mind about how this works. Okay? So, really what this is Here's what it really is. It's that word that starts with an S again. This is really substituting G into F. That's really what a composition of functions is. You're using a substitution idea. The operation dot that forms composite function is called composition of functions. Okay, great. So my words there, written in red, are the most important in that middle strip right here. Right? The middle strip right there is the most important thing. And then I'll actually show you the operations of what happens. And then tell you why I showed you that little thought bubble, because it really has everything to do with the thought bubble. So let's go right to this. Shucks. I do have to see this. I think I could see through it, though. No, I can't. Don't look. Don't look. Here, I'm going to freeze the screen so no one can see this numerical question. X squared and then x plus 1. X squared is f of x, right? Okay. Oh, you could see that. Darn it. I didn't hit freeze. So here's f of x, which is x squared. Here's g of x, which is x plus 1. And I'll tell you, the number one error for composition of functions is just taking the two functions and multiplying them. And you will get 0 credit for doing that. That's the student that doesn't demonstrate that they understand this one main thing that they need to focus on. The really new big idea today. Okay, now notice this should be written and could be written, not should be, but this could be written, find f of g of x. That's how that could be written. And then the very first thing you'd want to do is write it like this. And then notice we have multiple parentheses. When you have multiple parentheses in PEMDAS, like, when it's 6 minus 2 parentheses, but then it's 3 minus 4 here, and then you have brackets times 7. What do you do first, everybody? You do the 6 minus 2. You work inside out, right? All right, so that's the other thing, I assume PEMDAS. We've had a lot of PEMDAS issues, though, this year. So those assumptions I shouldn't assume. All right, so how do I work inside out? Well, it's actually this simple. G of x is just the name. G of x is just the name of this function. That's one thing about function notation. I can name functions differently. F of x, g of x, h of x, doesn't matter. And the very first thing I'm going to do is replace the name with its definition in this question. And g of x is defined by x plus 1 for this particular problem. And the people that don't get this, the very next question they ask is, where did the g go? Wait, what happened? Right? And you're missing the point that this is just a name, and all I do is replace it with its functional definition. And now that part's done. And then you know what this becomes? This is why I gave you the thought bubble. This becomes this question now. This becomes understanding what happens down here. That's all it is. In one step, if you understand this thought bubble, then you will never have a problem with composition of functions. Because now ignore that step and just focus on this. What's f of x plus 1? Wherever there's an x, I need to replace that with an x plus 1. And that's it. Well, that's not it. What do you think I have to do? Starts with an F. FOIL. I swear to dog, the people that still don't FOIL this and write x squared plus 1. If you write x squared plus 1 now in my class like this is like minus 3 points. I mean, I cannot have this happen anymore. All right? You need to understand that this is x squared, then x times 1 twice, and then 1 squared. How I got that is I thought about this right next to itself instead of writing it like that and then going from there. Question? No, that's a different f of x. Good question. No, this is a different question. Different definition. Okay? So, yes, I understand that confusion. This thought bubble is completely different. I just made that up. This is a different setup. F of x is redefined as this. That happens all the time. You get a section of questions, next section, f of x equals square root of x plus 2 or something. You know what I mean? So this is what f of x is now for this particular question. All right? Something different. Okay? All right. Great. Okay, now let's go back up to this. Let's go actually write this down. Same definition. F of x equals x squared. G of x equals x plus 1. But now find f of g of 3. This is a little different and a little bit easier. Look at how they break this down. You would not have to break this down this annoyingly. Different when we ask with a number. How do we work with multiple parentheses? Inside, say it, out. So you ignore the f of for a second, and you go, what's g of 3? And I could ask anyone what g of 3 is, and they'd be able to answer that question. G of 3 is just 3 plus 1, which equals 4. And that's what we see f of 4 next. Then I can ask anyone, hey, what's f of 4? And they know what f of 4 means. Go to the f function, wherever there's an x, replace it with a 4. Square it, final answer, f of g of a number 3 actually equals a number 16. So what I have highlighted is all I would expect you to write as a student. Maybe this, maybe proving that f of 4 is 4 squared. So they really overbreak it down and tell you how you do this step by step. So this is a different composition when we're dealing with a number. So you have f of g of a number, f of g of x. F of g of x is algebra. F of g of a number is evaluation. And getting a number is an answer. Give you a second to write all this down. I know you don't have your book to reference. That is a problem. It really drives me nuts. My daughter, luckily, one of them, of the two in the complicated math class, has the book. So I can actually thumb through the book and actually look at things and tell her what to look at. You guys don't, and it really, I can't stand it. I really wish you did have a book at home to reference the examples. This is why you got to take notes. Another argument for that. Your notes are your book. Okay, so let's take this down. Then here we go. This goes back to your question. Didn't you just say f? Here we go. F of x is now something completely different. Now a new setup of a question. There you go. You got it. All right, I got two more examples. And this one's a little bit smaller, algebraically. And by the way, the answer for my last composition of functions was a polynomial, so the domain was all real numbers, if you had to find the domain. Same thing's going to happen with this one. Okay, so again, two different kind of questions for composition of function. First one is the easier of the two, the numeric. F of g of 2. So just like the notes described, they completely ignored the f of first and just did g of 2. Hey everybody, what's g of 2? 3, 2, 1, go. Oh, that's not enough people. Come on. 6. Because all I'm taking is taking this 3 or 2 and plugging it into wherever there's an x in the g function. So g of 2 equals 6. Fine, I'll write it up here. But gosh golly, you should not have to write that. You should be able to just write 6 right here. And now ignore that happened and just focused on f of 6. Let's do better. What's f of 6? 3, 2, 1, go. Oh no, there is no understanding here. Take 6 and plug it into the f function. Now tell me, because I still didn't hear the answer. 3, 2, 1, go. 11. There you are. I had to fumble. No one yelled fumble either. Did anyone see this? You know, all year long, you guys fumble. I catch every single one. I fumble. I got 30 students and no one yells fumble. Okay, so 2 times 6 minus 1. 11. Is that a fumble? Did you do that on purpose? Seems awfully fishy. All right, so final answer is 11, a number. Is everyone okay? Okay, now let's do f of g of x. This is where this is different. This is simplification, not evaluation. Okay, so I won't ask you. G of x is 3x. Now this is where people say, hey, wait a minute, where did G go? G of x is just the name. 3x is its functional value. Quick question. We got another one. No, for this one, it's a number. The final answers can only be written in one way. When you have f of g of a number, the final answer is a number. When we have f of g of x, the final answer is an expression. Oh, do you want us to write this at the final answer? It's okay. You can. I'm just looking for the final number. Okay. Don't worry about it. And now it's f of that. Okay. And then again, if you could just one step at a time, and then ignore the last step once I've accomplished this, because now this turns into a very much like our thought bubble. How do I go through this whole progression of thinking? All right. So now here, f of 3x, sorry. In the f function, wherever there is an x, I'm going to replace it with a 3x. That's what that means. That's why the f is gone. The f of part means go to the f function and replace or substitute. All right, so the final answer for this is 6x minus 1, an expression, not a number. Inserting one function into the other. And then we're going to end with this one, which we do have 5 minutes. Boy, these Mondays with these this is why you got to take notes so you have a frame of reference, right? And then handle this kind of lecture, college type lesson. Very structured, though. Can't argue that. Really showing you the things here. Here's one problem with this, that dot's not big enough. So hopefully you can see that says FOG of x. So that you know that that's not multiplication. It's the number one mistake, and you will get no credit. 0 whatsoever if you think FOG of x means multiply two functions. It does not. It does not at all. Okay, now remember what I said about all our previous questions of even this composition. Like this last one, the domain is all real numbers. So if I ask you what's the domain of this composition, there is no problem. Whenever you have a polynomial, it's always all real numbers. The only domain issue we've had so far was the division, all right? When we can't have 0 in the denominator. And now you should know that we have some domain issues. Because now I'm dealing with a square root. Before we actually do this one, I'm sorry these are kind of so small. I should have made bigger fonts here, bigger cutouts of this. What is the domain of f of x? First of all, can I plug in -7? Yes or no? 3, 2, 1, go. Yes. What's -7 plus 7? 0, square root of 0. Can I plug in -8, -9, -10? 3, 2, 1, go. No. So this tells me what the domain is. It starts at -7 and goes to infinity. And then what's the domain of g of x? It's a polynomial, all real numbers. So no issue there. So I'm going to have to find the composition's domain, and then I'll just leave it at that. I just wanted you to be aware that there's going to be a domain issue for our final answer. Okay, so what's f of g of x? This is what we want to write first. F of g of x. And then the very first thing that we do, this is just the name. We're going to replace that name with its functional definition for this particular question. This one says f of x is equal, g of x, is equal to 2x minus 5. And then what are you supposed to do about that? I can keep with the highlighters. And I'll even draw lines. This f of thing just means go to this function, wherever there's an x, replace it with this. So the very next thing is square root of, not x plus 7, 2x minus 5 plus 7. Thank you, pen. Took that long to write all that. And hopefully you're starting to pick this up and why I gave you that thought bubble. You understand the thought bubble, you understand what I just did here. Oh, by the way, we do have to clean this up. This is the square root of 2x plus 2. Now, careful. What's the domain of this? Can I plug in -2? Think about that in input output. 3, 2, 1, go. No, so we have a domain issue. Can I plug in -1? 3, 2, 1, go. That's the beginning point, what we can plug in. The domain is -1 to infinity of this because it is. We have to keep this real. So the compositions domain ended up being a little worse than the originals. And that's a true story. Okay, so I do thank you for the majority of you paying attention all the way through and taking those notes and knowing the value of notes. Everybody needs to, especially when we do something new, so you have something to look at.